The Roland SP-404 is probably my favorite piece of gear. It has great effects, it has great pads, it's a great groove box. However, one big issue I have with it is the fact that if you want to resample something, you will need one hand. However, if like me you play the guitar or any other instrument that needs two hands, it's not very practical. So I developed the Romagnetics SP-404, which is a pedal that sends MIDI signals to the Roland SP-404. But before we talk about that, let's go back a bit. Before we start the video, if you want to do the pedal yourself, you have all the information, so the Arduino code, the computer code, as well as the schematics on the GitHub page in the description. And if you want to buy a copy of the pedal, I also have a link in the description. Enjoy. Now, since this project uses MIDI, I knew that I needed to use some kind of microcontroller, and the obvious candidate for that was the Arduino, so that's what I used. In retrospect, that's maybe not the best platform to use. The only reason is because you only have one UART, you only have one channel of serial communication, and if you want to debug, that can be a problem, especially because as we're going to see, MIDI uses a specific rate to transfer data, and that rate is not supported by the Arduino IDE, but that's a minor issue. The Arduino worked well for that case. The second step for me was getting MIDI to work and sending MIDI messages. So I looked online and in books how to send MIDI. So first of all, the connector, I used a MIDI 5-pin DIN. I could have used a TRS connection, but I like to use 5-pin MIDI more. And the second step was, what do I need to connect to the 5-pin MIDI? And I didn't find a lot of information on it. Actually, on books and online, I find the wrong information, that you only need one resistor. It's 220 ohms if you have an Arduino. Actually, upon further verification, it works with only one resistor, but the MIDI specification specifically says that you need two. So in the first prototype I use only one, but in all the other models I use two, and it works better. So beware, if you use a MIDI out device on the internet, it says that you only need one resistor, but it's better with two, as you can see here. I soldered a resistor to a MIDI female connector and tried to play a simple scale, and it worked. And now I think it's a good time to tell you a little bit more about MIDI. So it's not an in-depth video, but basically the way that the MIDI notes work is that you have 3 bytes. The first byte is going to tell you whether it's a note on, a note off, or a CC signal or other signals. Then you will have, on the second part of the first byte, you have the MIDI channel, so you can choose between channels 1 to 16. And then you have the second bit and the third bit, so it depends on what type of information you've sent. If it's a note, the second byte is the note and the third byte is the velocity. And if you're using a MIDI CC, the first one is the CC and the second one is the CC value. Then I had to think about the design of the pedal, and I'm thinking buttons and how to select the notes. So the obvious first choice is to have a push button to send the note. And then, since I didn't want to send only one note, I thought about it, but I think one note is a little bit too limited. I settled on 3, and so I got this 3-way switch, and each position will send a different note. I have it mapped to pad 1, 2 and 3 in MIDI mode A. I will talk more about modes and everything you can play with the FS-404 when we talk about the companion software. But yeah, we have the 2 switches, so the selector switch and then the data sending switch. Then for the power, I wanted to have a standard 9-volt guitar pedal power. I know that the Arduino can be powered through USB, but yeah, at the end of the day, it's a guitar pedal. So the easiest way to power it is just to use a standard barrel 9-volt. The next step was using, and this is quite irregular for guitar pedals, but I like to have an on-off switch. Very few guitar pedals have that, and personally I don't like it, so I did it on the side, so you can toggle it on and off if you want. And then I need to address the elephant in the room. That's the 4 LEDs. Don't worry if you want to do the pedal yourself. Everything I uploaded on GitHub only has one light, but for people who want to buy the actual pedal from me, I added 4 LEDs. It looks like the Sagitta constellation. That's where I got the idea from. And so those are the 4 main stars from the Sagitta constellation. The reason I did it like this is because you have 3 positions. Each position is one light, and then the one on the upper right is the status light, so the on-off light. If you build it yourself, you will only have the one light here at the top. So that's about it for the design. And then I had the button placement. Here there's something that I changed between my plans and when I actually drilled the pedal. It was easier for me to have the MIDI socket on the side, but I thought if you have a lot of MIDI pedals, if you have a lot of guitar pedals next to each other, it's not going to be very practical to have a MIDI cable stand out. So I managed to fit the power barrel and the MIDI together. It's really tight. There's less than there's about a millimeter of leeway that I have for that project. So yeah, every time I drill a pedal, I'm quite stressed about it. After drilling all the holes, I had to decide which kind of finish I would have for my pedal. It was raw aluminum when I got it. And so naturally I thought about painting it, but there was no solution that was satisfactory for me. Everything regarding paint, I feel like the only good paint you can cheaply have for aluminum is coating paint, and I wasn't ready to buy an oven and a compressor specifically for that project. So I thought about just sanding the pedal and polishing it, which is what I did. I used sandpaper that's gradually smoother and smoother. So I started with 240 and I finished with 1500. That was for the prototype. Then later for the actual product, I added 120. And I think for my future pedals, I will probably start even lower, probably at 60. And I will probably use an electrical sander because it takes a lot of time. It takes me about, I would say, more than an hour for one pedal. The next step was soldering everything and putting all the elements within the pedal. It's actually a tight fit, especially if you have 4 LEDs. I think if you have only one, it's okay. The only difficult part, and the one that I changed between the prototype and the actual pedal, was the Arduino itself. So the board, for me, it cannot just be freely in the middle because I'm using the USB to upload the data onto the pedal, so I need to use the USB socket. And on the prototype, I just glued it inside and I just soldered everything in place, which is kind of hard because since I needed to have the USB out, I soldered it backwards, so it was really hard to get all the connections to work. And that's one of the biggest changes I made between the prototype and the final product, was adding JXT connectors. So I would solder the Arduino to the connectors first, then I would prepare everything and put it within the socket. So I have 3 JST sockets for 4, 5, and 6 holes. Some of them, I think 3 in total, I don't use, but that's totally okay, and it allows me to do everything in a cleaner way. The second change was regarding how I put the Arduino in the pedal. So for the first version, I basically had spacers, like brass spacers, glued onto the Arduino, but overall it's quite a messy affair, and I'm not sure I would have been able to get the Arduino out if there was any problem with the board itself. So I replaced it with a plastic part. I used a model available online, but I changed it quite a lot, and I think for future pedals I would just use a custom, I will make a custom 3D printed part, but basically that allows me to just slide it in, and if there's any issue during the build, I can just take it out, and since it's JXT connectors, they just pop out, and it's way easier. The main drawback, of course, on both modifications is the fact that it takes way more time. If you just solder something into place, it takes way more time than soldering the female connector, then crimping the male connectors. I mean, it's a little bit messy, but once again, it takes more time, but you have something that's way cleaner. You can see the result here. I have a picture of the prototype on the left and on the actual product on the right, and I think it looks way better. I haven't talked too much about the Arduino software yet. Of course, when I built the first prototype, I already had some code in mind. It's very simple. As I said, there's 3 bytes, so the pedal sends 3 different bytes. Then, of course, I had a lot of different issues. The first one being, of course, you want to send a note off after you send your note on, otherwise you are going to have a lot of different issues that are going to arise. Mainly the receiving device probably will not be able to understand a note when it's played again, and a lot of different bugs can happen with that. So if you send a note, you need to have a note off sent afterwards, which is not the case for the CC messages, for example, because they don't have an off or an off position. The biggest thing that I needed to implement within the code was a way to update the notes through the USB. And the main issue is that the Arduino has different types of memory. Once again, I'm not going too much into the details, but you cannot just have serial, which is in this case USB. You cannot have the computer tell the pedal, hey, I want you to change that value in your code. That's not possible. In order to do that, you need to access what's called the EEPROM memory, which is a certain kind of memory that can be accessed and saved. And so that's exactly what the pedal does. It reads the EEPROM every time it boots on, and then it uses those values. However, you cannot, through serial, I mean, in this case USB, you cannot tell to the pedal, hey, write EEPROM here, like write that value on EEPROM memory 1. In that case, that would be memory 1, 2, 3 for one node, right? Because it's 3 values, 3 bytes. So the pedal needs to know when it receives a message that it then needs to update the EEPROM. If you do stuff with EEPROM, it's common knowledge, but I'm saying that in this video. Be careful not to rewrite your EEPROM every cycle, because you have quite a limited amount of rewrites that the Arduino can do for the EEPROM, so you have to be economical with how many EEPROM write you do. With EEPROM read, you're free to do as many as you want. So in the case of that pedal, it would read the EEPROM every time, but it will only write the EEPROM if we have a new value. So that's basically the way you want to do it. I had issues regarding debouncing. So if you push a button, sometimes you will get 2 inputs. So that's an issue that exists, and basically the quick version to do this is checking at a couple of milliseconds away if you have a button pushed. And one more thing that I needed to put into the code was, if you push the pedal, you don't want to have an infinite amount of triggers. Especially in our case, we're using the SP-404. We want to send one note and that's it. And so I implemented an additional step that checks if the pedal was already on when reading the value, so it doesn't spontaneously trigger when you don't want it to. Now, regarding the companion app, since I'm quite the beginner in C++, that was actually my first C++ project, I'm not going to talk about the code too much, because I think I will modify it quite a lot in the future when I learn more about the language. But from the UI perspective, you can choose between 5 modes. So everything I'm about to say, of course, is applicable to Note 1, Note 2, and Note 3. And you can either use a pad in mode A. So if you don't know, the SP-404 MK2 has 2 MIDI modes. There's a lot of videos about this. Mode A has 10 MIDI channels, so MIDI channel 1 through 10, and every pad has a note within that MIDI channel. Then there's MIDI mod B. If you use a lot of MIDI channels already, that's probably the one you're going to use, because in that scenario, instead of using 10 MIDI channels, the SP-404 only uses 2, and you can choose that. You can of course choose that in the app as well, like channel 1, 2, 2, 3, 3, 4, etc. I think up to 12. Then you have the notes. This is not specific to the SP-404, but of course you can use that pedal with whatever piece of gear you want, and I thought that using a MIDI note functionality was a good idea, so I added the notes, and I also added CC, so you can send the CC. The last mode is the MIDI commands. All the MIDI commands specific to the SP-404 are actually MIDI messages, but I mapped some of them directly here, so you don't need to read the manual and know exactly which CC you're going to use. So that's how the app works. You connect the FS-404, choose your 3 pads / notes / MIDI control, and then you upload it to the pedal, and you get a confirmation message that everything was uploaded right. You have to be careful when you do that. You need to disconnect your MIDI pedal, because as I said, there's only one UART in the whole Arduino, so if you send notes at the same time as you receive some, there's going to be some issues. Here is a simple example on how I played 3 different pads with the FS-404. And that's about it for this video. That's the final pedal. It's not connected right now, but that's the one that I've used for all the tests. It's the prototype. If you want to do it, you have all the information in the video. And if you want to buy one, not this one because that's the prototype, but another one, I'm going to do a couple. One thing that I might change in the future, if the FS-404 is successful, I will probably switch from the Arduino to an STM32 because I think overall it appears to be a better platform to do MIDI stuff, because MIDI uses serial, and so if you want to test, it's better to have 2 channels, but that's another discussion. Please subscribe if you enjoy, and the next project is also going to have to do with MIDI, but it's going to be quite different, and it's definitely going to need an STM32 because I'm going to use multiple UARTs to use USB MIDI and MIDI together. So yeah, I hope you will like this project as well. See you.